Hello, students, and welcome to our lesson on applications of solving equations. This is mostly going to be a lesson on how to turn words into equations. The actual solving part, we mostly have practiced so far. There are going to be various types of equations moving forward that we'll introduce, but all of the ones we've learned so far, so one and two step equations, along with multi step equations that require simplification, those are the kind of things we're going to see out of these word problems. So again, really, this lesson is about how to turn the words into the math. And it's going to be pretty systematic. So hopefully this will uncover, some secrets to what us mathematicians are doing. A couple general strategies first. And the first one is by far the most important. If you ever want to see good old Mr. K get exhausted, it is ask him a question about a problem before you have read the problem. Okay, so many times students will ask me things, and then I go, well, did you read the question? And I don't mean that in a way like you should understand. I literally mean, hey, it says the answer to your question directly in there. You just didn't keep reading. So, rule number one, general strategy step number one, read the entire problem. Usually the question comes at the end of the problem. Okay, so read the problem first. Then we need to get organized. Okay, so we are going to organize the important information. Some of these problems, there's nothing to organize. Okay, it's just going to be what I call a direct translation problem, where you can just go straight from words to equation. But in other cases that we'll see later in the lesson, you're going to want to draw a picture or make yourself a list, some sort of organization. So read, then organize. Then what is usually the harder part, which is to write an equation that models the scenario. And we use this word in math a lot, this word models. Okay, this means we want to represent a situation with mathematics. So we want to be able to write down an equation that represents the scenario or models the scenario. All right, and then the fun part is we get to solve and interpret the solution, where the interpret part really just means to answer in words. We're going to have nothing but word problems here, where the first ones have no context, so those answers will be nice and short. But when we get to the real word problems with context, you need to put your answer in context, meaning interpret what that number you got actually means. All right, so before we dive into it, some frequently used words. I'm going to read through these all, but these are here mostly for you to reference back to. For addition, we have the word plus, sum, total, increased by, and more than. These are very common phrases that tell us that we should be doing addition. Okay, obviously the word plus is what we call the symbol, so that one's not too bad. But the word sum means directly to add together two quantities to find the sum. And then increased by and more than are going to get used a lot in these lessons and in these problems. For subtraction, we have minus, difference, decreased by, less than, and subtracted from. Where less than, decreased by, and subtracted from will show up a lot in the ones we're doing. And this word difference is something that people really tend to forget, that the word difference just means to subtract. Okay, so whenever you're asking what's the difference between two things, that always just means to subtract the newer thing from the older thing. So what's the difference in my height from now since I was 10 years old? I do my current height minus my 10-year-old height. But it's subtraction is what difference means. For multiplication, we have times, multiplied by, product, and then some other examples such as the word of. We'll see a lot where of always means to multiply, but usually it's in the context of we'll say like half of X or half of a jar of peanut butter. But that really just means to multiply the half, which is a number, times whatever the object is. So half of X means 1/2 times X. And we also have words like twice, thrice. Those are used a little bit less. The word twice is pretty common, but generally we will use the actual number and say multiplied by. But that word of shows up all the time. So like half of x, we need to know that that means 1/2 times x. For division, we have divided by. The word over, where if you think of a fraction, we'll say like 12 over 3 means 12 divided by 3. The word quotient, of course, is division. The word per, which really means each. So like think, I need 1/4 cup of sauce per pizza. So like each pizza needs 1/4 of a cup of sauce. That means that we're dividing though. Or if you think miles per hour, that means miles divided by hours. All right, and then ratio of, when I introduced fractions to you in topic 7, which was our visualizing fractions lesson, we talked about them as ratios, where if I have a ratio, that really just means one thing over the other thing, or division there. In equality, we have equals, means, of course, an equal sign, but we also have the word is, or past tense of that. We might see the word, oh, we're at the wrong thing there. We might see the word was. Okay, so is and was both mean equals. Is the same as is just really spelling out, hey, this means equals. Results in means equals. Amounts to means equals. And I mean, there's quite a bit of other things that could mean equality, quite honestly. But the most common thing we're going to see is the word is. Okay, that word is going to mean equals in quite a few spots for us. So, all right, now we're going to translate. Everything you see here, numbers 1, 2, and 3, are going to directly translate to an equation. So let's read number 1. 5 times the sum of 3 and twice a number is 70. Find the number. So now notice I read the whole thing first because the end of it is what tells me what I'm looking for. It says find the number. So that means we don't know what the number is. So I'm going to call that number X. You can choose whatever letter you want. Okay, variables can be anything you want. A lot of people would use N for number, but I just like to default to X because I'm a basic math guy. It's just the way it is. But feel free to use whatever variable you prefer. And now we're going to find that number. So we have to translate the rest of the words into an equation. Where it says the word number, that is where I'm going to put my X. Okay, so when I read through this again, 5 times the sum of 3 and twice a number is 70. When I get to twice a number, that number is X. Okay, that's what we just determined at the end. We're calling that number X. All right, let's go word by word. It starts off with 5 times. Okay, 5 is just a number. The word times means to multiply. So I'm going to write 5 and then a multiplication symbol. So just a little dot there. Don't use X for the multiplication symbol, by the way. Use the little dot. So 5 times, and then it says the sum. Because it says the sum, I'm going to put parentheses with an addition symbol in the middle. Okay, because the sum is going to be at least 2 things added together. If I needed to add more than 2 things, I could just move my parentheses over and put multiple addition symbols. But sum is going to mean to add some things together. So parentheses to group those things together with the addition in the middle. Then it tells me what I'm doing the sum of. So it says 5 times the sum of 3 and twice a number. So you always do it in the order it appears in. So it's 3 and twice a number. So I'm going to put the 3 in the first spot, and then twice a number here, I'm going to double underline. Twice a number means we are going to multiply 2 times x because x is our number. So it's 3 and 2x. Twice a number is 2x. Then the easy part, we have the word is. That just means equals. Then on the other side, we just have a plain old number, which is 70. So 70 at the end. So this whole thing just converted to 5 parentheses 3 plus 2x is equal to 70. So now solving is no big deal for us. We've learned how to distribute here. So I'm going to distribute the 5 to get 15 plus 10x is equal to 70. And now it's a 2-step equation where I'm going to use the additive inverse to move the 15 to the other side by subtracting. That leaves me with 10x is equal to 55. And then I'm going to use the multiplicative inverse to divide both sides by 10. And that is going to leave me with my solution, which is x equals 55 over 10 can be reduced to be 11 over 2. You could turn that into a decimal and say 5 and 5/10, so 5.5. But in this case, 11 over 2 is going to be my preferred answer. All right, number 2. We have 2 more than a number is 12 less than 3 times the number. And again, it says find the number. So wherever it says find the number, that tells me that I need to define a variable for the thing I'm finding. All right, now let's go back through. It says 2 more than. 2 more than means to add to. But whenever you see language like this, it always looks better if you put it at the back of the thing. So 2 more than tells me to add 2, but I have to add 2 to something. So what am I adding to 2? Well, I'm adding 2 to a number. Okay, so it's 2 more than a number, and that number is x, we said. So this is x plus 2, where notice that 2 more than puts that plus 2 in the back of the number. Okay, then it says is. Is always means equals. And the other side, we have 12 less than 3 times the number. So just like 2 more than meant to add 2 in the back, 12 less than, very similarly, means to subtract 12 in the back. But what am I subtracting 12 from? Well, it says 3 times the number. So I'm going to put 3 multiplied by my number, which is x. So 2 more than a number is x plus 2. And 12 less than 3 times the number is 3x minus 12. Once we have that down, now the solving steps. This is just a 2-step equation. I'm going to go ahead and subtract x from both sides. That is going to leave me with 2 is equal to 2x minus 12. The reason I moved the x to the other side instead of moving the 3x was because it keeps my variable term positive. I have a positive 2x now. I'm going to add 12 to both sides. Right, that is going to leave me in the next line with 14 is equal to 2x. Notice, by the way, that when I run out of vertical space, the math doesn't look as pretty. I have to use arrows. The work gets more confusing. So this is a good lesson for you on why we work vertically in math. That way we don't have to do this nonsense I'm doing right now. But all right, we're left with 14 equals 2x. I'm just going to go ahead and divide both sides by 2. That's the multiplicative inverse here. So I'm going to get 7 is equal to x. And, oh, whoa, wait a second. 7 equals x. Did something go wrong here? No, we're good. 7 equals x. In my notes, I was wrong. I wrote 14 over 2. Had an extra 2 there. But no, we're good. 7 is our number. I want to clarify, by the way, we're supposed to be interpreting these things, right? So at the end, what we should actually be doing, it says to find the number, and all I've written down so far is x equals a number. So we should actually say for the first one that the number is 11 over 2, and for the second one, the number is 7. All right, and if we ever want to double check any of these, just like with normal equations, we can always plug them back in. So for number 2 here, where we just got 7, it says 2 more than a number. Well, if that number is 7, 2 more than 7 is 9. So we got to make sure the other side's going to equal 9. The other side says 12 less than 3 times the number. 3 times 7 is 21, and 12 less than that is 9. So both sides here are going to represent 9 for us, which is exactly what we hope, right? All right, number 3. We have 3 less than twice a number is 19. Find that number. So we're going to name that number x again. It says 3 less than twice a number. 3 less than tells me to subtract 3, but I have to subtract 3 from twice the number, which is 2x. Then the word is means equals for me. And this time we just have a nice easy 19 on the other side. So we just copy down that number. Solving this one is going to be nice and simple. We just have to add 3 to both sides. Get that 2x isolated. So we have 2x equals 22. And then when we divide both sides by 2, that is going to leave us with x equals 11. So then the interpretation result is to take that and say that the number is 11. All right, so interpreting at the end basically means answer the question, right? And this is the thing students tend to mess up when they don't read the question. They don't know what they're answering. So you got to read all the way through. It says find the number. If I tell you to find a number, you would answer me with the number is 11. You wouldn't just say x equals 11 because there was no x in my question. Okay, we invented the x, but the number is the thing I'm looking for. All right, let's do something now where we're going to have to draw a couple pictures. So the first one says, the first one actually doesn't get a picture, by the way, but the other two do. The first one here, number 4, says a patient receives 3 doses of a medication over 3 days. The total dosage administered over the 3 days is 96 milligrams. If each day's dose increases by 1 milligram, how much medication did the patient receive on the first day? So we are trying to figure out how much they received specifically on the first day. Since we are getting 3 doses here, we're going to have 3 different amounts for each day. We just want to find out how much the first day was. So our first day's dose, I'm going to call X, just like before. But before we solve for X, we need to make sense of what's going on here. The patient is receiving 3 doses, and it's going to equal a total of 96 milligrams, this says. So before I get X involved at all, let's just say that dose 1 plus dose 2 plus dose 3 has to equal 96 milligrams. Okay, it says the total dosage, so that's how I knew I was adding up these dosages. That word total tells me to add. I don't know anything about the doses yet, though. I just know together they give me 96 milligrams. All right, so now we're solving for the dose on the first day. So we know that dose 1 is our X. So I'm just going to replace it with X right there. But now we need to write something in place of dose 2 and dose 3 that involves X, because we want to have only one variable in our problem. That way we can solve for it. So we have to use this middle line, this fact that each day's dose increases by 1 milligram. So if the first day's dose is X, then the second day's dose is going to be X plus 1. Okay, where I just increase it by 1. Okay, that means to add 1 to the dose. But then the next day, so dose 3, I'm going to increase the previous dose by 1. So it's not going to be X plus 1 again. It's going to now be X plus 1, which is X plus 2. So when I add up these 3 doses, they're going to be 96, but I can represent each dose as X, X plus 1, and X plus 2. Now this equation is going to not be too bad to solve at all, because those parentheses that I put there are strictly so you could see what each dose is, I should say, but they don't actually affect our addition here. So when we combine like terms, we can put all the x's together to get 3x. 1 plus 2 gives me 3, and this equals 96. Now, just a 2-step equation, so we are going ahead and subtract 3 from both sides. That's going to give us 3x equals 93. And we'll divide both sides by 3 to end up with x is equal to 31. So now that's all well and good. We got x equals 31, but the question did not mention x anywhere. So now we just need to answer this question in words. We need to interpret our result. The question asked us how much medication the patient received on the first day. So this x equals 31 represents that the first day's dose was 31 milligrams, where I need to have units here because those milligrams are relevant to this dosage. Okay, you can't just say 31 in a hospital setting or nobody's going to know what you're talking about. In this case, the first day's dose was 31 milligrams. All right, number 5. Now we're going to have to draw a picture. A rectangular hospital room is being prepped for a new patient. The length is 3 meters more than twice the width. If the perimeter is 54 meters, what are the room's dimensions? So the actual question came at the very end there. What are the room's dimensions? And we are talking about a rectangular room. So a rectangle has dimensions of length and width, where I'm going to write L and W for length and width, just like the convention would be. So instead of X here, we're actually using different letters, L and W. Now, whenever a shape is described to you, I recommend you always just start by drawing that shape. So here, I drew a rectangle because it said it's a rectangular hospital room. If I were to label the length and width on here, I always think of the width being W at the bottom and the length being L on the side. Doesn't matter because you could just turn it sideways and the picture is still a rectangle, but I'm gonna label it bottom width, right side length. All right, so now we want to start using what's in this word problem to actually get to a solution. So we have in the middle line that the length is 3 meters more than twice the width. So we're going to turn that into an equation. It says length is, that's going to tell me L equals. Okay, remember, is means equals, and we already said the length is L. So we have L equals 3 meters more means I'm going to be adding 3 in the back. But what am I adding 3 to? Twice the width. So that's going to be 2 times W. So altogether, I have length equals 2W plus 3, or L equals 2W plus 3. So in my diagram, that's what I'm going to write. Where I wrote L before, I'm going to say equals 2W plus 3. Great. Now we have a middle line that talks about the perimeter. So it says if the perimeter is 54 meters, we're supposed to be able to solve for the room's dimensions. So I'm just going to copy down perimeter equals 54 because it says perimeter is 54 meters. So perimeter equals 54. And then where I wrote the word perimeter, I'm going to replace it with an equation that represents perimeter. So we have a rectangle here. The formula for perimeter of a rectangle is 2 times length plus width. So we're going to have 2 times length plus width equals 54, where all I did to get that was know that the perimeter of a rectangle was all 4 sides added together. So if we add together the length and the width, that's 2 of the sides, but then we still have a top side and a left side, which are another L and W. So that's why we multiply it by 2. But 2 times L plus W has 2 variables in it. We want to only have 1 variable. So what we're going to do is replace the L with what we know L is equal to. We know that L is 2W plus 3. And then W is just plain old W. Nothing changes there. But notice now my equation reads 2 multiplied by 2W plus 3 plus W equals 54. Now I only have 1 variable. This means it'll be nice and easy to solve. If I combine like terms on the inside of these parentheses, I have 3W plus 3. If I distribute the 2 inside of the parentheses, I get 6W plus 6 is equal to 54. And now it's a nice 2-step equation. So we can go ahead and subtract 6 from both sides. And after I do minus 6 and minus 6, I'll bring my next step up to the top. I have 6W is equal to 48 left. So I'll divide both sides by 6. And this is going to leave me with W is equal to 8. Now, if the question was, what is the width of the room? I would be done. I would just say the width is 8 meters. But that's not the question. It says, what are the room's dimensions? So I now have to use the fact that L, or length, is equal to 2W plus 3 to solve for the length. So I'm now going to say that length is equal to 2 times that result I just got, which is 8, plus 3. Okay, I'm going to plug the W into the length formula. This is going to simplify to be L equals 16 plus 3, which is 19. And so I now have both the length and the width, so we can go ahead and interpret our result. The room is 8 meters by 19 meters. Or in other words, the length is 19 meters and the width is 8 meters. But we need to make sure we interpret that result in words whenever we're given a word problem. All right, last one, number 6. The triangular warning sign on a biohazard container has angles in the ratio 1 to 2 to 3. What are the measures of the 3 angles? So it's asking me to solve for what are the measures of the 3 angles. So I'm going to have to give each one a variable here. I'm just going to call them X, Y, and Z. Okay, just 3 letters that I know are nice and easy to use. So we want to figure out what this triangle is going to look like. So I'm going to draw a triangle real quick, and I'm going to label the angles as X, Y, and Z. Okay, those are the 3 angles of my triangle. So now we need to make sense of this whole ratio 1 to 2 to 3 thing. So this means that if the first angle is of size 1, so 1 degree, the second angle would be that times 2, so 2 degrees, and the third angle would be that times 3, so 3 degrees. In our particular case, though, we are naming our first angle x. So this ratio, 1 to 2 to 3, can be rewritten as x to 2x to 3x. So it tells me that if my first angle is x, instead of my second angle being y, I can actually just call it 2x. And instead of my third angle being z, I can just call it 3x. So my picture now has three angles that are all written in terms of x. X, 2x, and 3x. Okay, great. That doesn't feel like we're really any closer to getting to an answer though. We wrote everything in terms of x, which is good, but what do we solve for here? How do we write an equation? So this one is going to require that we know a little bit of sum and summon about triangles. And the thing we are expected to know about triangles is that in a triangle, the three angles, which in this case are x, y, and z, are supposed to add up to 180 degrees. So with our specific situation, this actually becomes x plus 2x plus 3x is going to equal 180 because we replaced the other two angles with 2x and 3x based on our ratio. Now solving becomes not bad at all. Those combine to just give us 6x on the left equals 180. So if we divided both sides by 6, we end up with x is equal to 30. And what this tells me is that my first angle is 30 degrees. Okay, but we don't just want the first angle, we want all three angles. So now we have to go back to our ratio, which gave us this x, 2x, 3x situation. If we know that x is 30, that is going to mean for us, okay, based on x being 30, we then have 2x is 2 times 30, which is 60, and 3x is 3 times 30, which is going to be 90. So we can then say that this triangle on this biohazard sign has angles. So the angles are 30 degrees, 60 degrees, and 90 degrees. And that is going to answer our question here. Now, this isn't part of the question, but as a follow-up, a 30, 60, 90 triangle, well, that 90 degrees is a right angle. And so I can actually draw this triangle a little bit better now that I know what the angles are, where we have a right angle in the bottom, a 30-degree angle up top, and a 60-degree angle on the right side. And so once we know what the angles are, we can actually draw a better picture. So notice my starting picture was just a generic triangle, but by the end, I can tell you exactly what that thing is going to look like. In this case, it's a 30, 60, 90 triangle. That's all I have for you guys. Hopefully you're getting the idea that pretty much all words can be turned into math. We just got to know what means what. And in this case, the most important things, we're understanding what means to add, divide, subtract, multiply, and really, what does equals look like? So that word is the key giveaway that you have an equal sign, and we're going to be using that all the time moving forward. So hopefully this one stuck, and I look forward to doing the practice with you guys.